Hello fellow engineers, today we will be discussing the applied calculation of a half-wave rectifier with resistive plus inductive load. Now a half-wave rectifier is usually operated with just a resistive load, which means a half-wave has been cut off and then a half-wave for the positive half cycle will move on while the negative half cycle will be cut off. Now when an inductive load comes into play, the circuit reacts differently. In order to find that out, we will perform a calculation. According to our question, an impedance of 10 plus j 5.7735 ohms is given, an RMS voltage of 230 volts, frequency of 50 Hz. We have to find out the expression for the load current, draw the output voltages and current waveforms, find out the mean output voltage and the mean output current. In order to perform our necessary calculation, we'll need a little bit of working to do. First of all, we have this RMS voltage and we'll have to convert it into our peak or the maximum voltage. Next, since we have Z, this is in polar form, we'll have to rectangular form, we'll have to convert it into a polar form. That means we have to find out its magnitude and its angle. The magnitude and its angle are calculated. Now since it is an RL load, it'll also have it'll not only have a steady state component but also a transient component. So for the transient component, we'll have to find out its time period or tau. Now since we have all of our values, we'll perform our necessary calculations. In order for our expressions, we need the output waveform, the output expression, right? So since we know that the circuit is composed of a steady state component and a transient component, both will be added to play. So the steady state component will be calculated using Em upon Z sine omega t minus theta, while the transient component, since it dies out, is an exponent term. After its necessary calculations, we have our values. Now coming to our graphs. Since this is a resistive plus inductive component, first of all, for the first positive half cycle, what happens is that the positive of the terminal is on the top and the negative is at the bottom, which means this diode is forward biased. Since it is forward biased, what will happen is the voltage across the supply will automatically go towards the load, assuming that the diode is ideal. So we'll have the output voltage will be following the input voltage for 180 degrees for the positive half cycle. Now when it comes to a negative half cycle, the diode should cut off. Now since we have an inductor, the inductor's property is to resist the change in current. Now since the polarity has changed, the inductor will however resist it. For how long? For the